So when we are finding the shape of irregular figures, you are going to need to break apart or separate. We need to know all of the figures that are contained within that composite shape. Okay? So you're going to break them apart. Now, I don't mean literally tear them, but you draw lines, like dotted lines or something, to separate. Separate the circles, the triangles, the rectangles, the squares, the trapezoids, all of those type of things. All right. So then we find the area of each individual figure. And then, let's add something here. Then combine them. In other words, we're going to combine them, add, or subtract. We can always take away, and I'll show you how to do that. All right, so let's write that in there. Add or subtract all of the areas. And that will give you the area of that shape. Okay, for the perimeter, so we're going to find the area, which is, what is the area? Inside, outside? What side?
Inside.
Inside, good. So it's all of the inside area, and this particular one is the shaded part. For the perimeter, you need to add all of the sides. Now, one thing you need to remember when you're adding all of the sides together is because you're going to have shapes that are stuck together, that a normal outside part of a rectangle or square might become an inside part. In other words, when you stick a circle on top, like an ice cream cone, okay? When you stick a circle on top of that, you don't have the one side where the circle was, where the circle is, okay? All right, you don't. All right, so we just add the outside. That sounds the exteriors. Let's use that. I like that better. Exterior. Exterior side. Okay? So that's just going to be everything that's on the outside. So literally, it's just like a little. You just put your pencil down there and then just trace the whole outside of the shape. That's what we're going to find the perimeter of. All right, so let's look at this irregular figure here. Somebody tell me what they see. Caleb.
I see a rectangle and a square.
You spy a rectangle and a square?
Yes.
All right. Two rectangles? Anybody else see anything differently? All right, so two rectangles. Now, here's what I would do. The first thing you need to ask yourself are, what shapes that is an important question. What shapes are in the figure? In this particular one, I don't think we're going to be able to come up with a square per se. Because all you want to do is draw kind of straight lines to cut them apart or separate them. Now you can do it one of two ways in this one. What I see, like my first inclination, and I'm not saying this is right because you can break it up however you see it, would be to go like this. Okay? That would be the one that I would see. So I would separate them. Let's write that too. Separate the different shapes. So we're going to separate the different shapes. Okay? And then I that would fill in any missing sides. That's a good one. Fill in or find missing side lengths. Okay. All right. So we have how many missing side lengths here? 2, right? How are we going to find them? Well, this side right here is what? The top is 6. So this side right here doesn't go all the way across. It goes what? Stops right there, right? So if the whole thing is 6 and this part right here is 2, what do we think that side, this part would be? 4. Okay? 4. So let's fill that in. So we found the shapes, 2 rectangles. We separate them. So we could have separated them this way too. Right? So for this one and this one, like a long rectangle, a little one, doesn't matter. You can separate them however you see it. Okay? But I went this way. It's just my natural, like what I see would be to cut it that way, but we can certainly cut it vertically. All right? So now we only have one missing side, which would be this one right here, this left side. Okay? The longest side. Now we know from here to here is how much? No, just from here to here is the same as from here to here. So that would be what? 4. And then from here to here is the same as from here to here, which is what? So what's the whole thing? 7. All right. So now we have all the sides, so that makes it easier to find the perimeter. And let's find the area. The area for this one right here, for this rectangle, the top one, is going to be length times width, right? Now you need to know, look, if you don't know the formulas, look on that reference that sheet right now until you get your other formula sheet. But this one is going to be 6 by what? Right? 6 times 4? 24. Now remember, area is squared, so it's 24 centimeters squared. Make sure you indicate the units on there. So 24 centimeters squared. So we have the top rectangle. Now we're going to need the bottom one. Okay? It's almost a square, but not quite. What are the dimensions of those? 4 by what? So 4 times 3 equals 12 centimeters squared. Now to find the area, I'm going to add 24 plus what? 12. It's going to give us what?
36.
Make sure we write centimeters squared. So the area equals 36 centimeters squared. Easy, right? Rectangles are pretty easy. Then we're going to get into semicircles and triangles and trapezoids. But just separate them into the regular shapes, and you won't have a problem. Now, great question. When would we subtract? Ooh, Horseshack. Welcome back, Carter. Horseshack. No, before dating myself. All right. So when would we subtract? Does any? Can I erase this?
Yeah.
All right. When do we subtract? Does anybody see a big shape like a big rectangle? right? If I did that, if I made this, if I filled this in, we'd have a big what? Rectangle, right? So we said this side was 7. So I could do 6 times 7, which would be what? 42. So that whole thing would be 42. And I know this little part right here, the cutout, is a 2 by what? 3.
So it's 6.
So a 2 by 3 would be what?
42 minus 3.
Would be 6, right? 2 times 3 equals 6. So then I could do 42 minus 6, which would be what? So we can do it that way. Right? So we can separate it into little shapes and add them together, or we can take that one big shape and then subtract it out. Now you won't always be able to do it that way, but it's just how you see it. That some of you might find that easier. Mia.
Yeah.
That's coming up, isn't it?
Yeah, where you just like bridge it, like
Something circular.
yeah.
Yeah, but that's why you do the randomness.
Oh
We might have a makeup pie.
Yeah.
All right, let's go to the. Everybody familiar with the gym? When you go down to the gym, look for that shape today, right here.
Oh, yeah.
What would that be? Free throw line, right? Free throw key, the lane. All right. So, what 2 shapes do we have here?
Half a circle and a rectangle.
So we got a rectangle, right? Half of a circle. Everybody see that?
No. Yeah.
Yeah? Okay. So the rectangle should be pretty easy, right?
Yeah.
19 times what?
12.
Which equals what?
228.
228. 228 feet squared? Alright. Now we've got the circle. Who can tell me the formula for the area of a circle? Anybody remember?
Up 2 times 12 times 3.14. Something like that. No.
The area of a circle is what? Pi r squared, right?
So it's 9.8.
Pi r squared. Alright.
Yeah.
So we have to do 2 things though with this semicircle, this half circle. Okay? We've got to find the radius because they give us the what? What is all the way across? This would be the diameter. 12 would be the diameter. So each side would be 6, right? So R would be 6. Remember, we're going to say pi for dessert. So we got 6 squared times pi, right? So we get, how many pi's do we have? We have 36 pi's, right? 6 squared is 36. We all agree on the same page on that? 36 pi's, okay? Now, here's what I would do. I would stop right there. I never like, matter of fact, when you get into higher math, you're just going to leave things in terms of pi. Because we know pi is what kind of number? Irrational, right? So it's not really exact. So when we get, just like we have variables, pi is really a variable. It's a symbol that we put in place of the number. So what we're going to do is leave things in terms of pi, generally. When we get, you know how remember how you learned how to, you used to have to change all of your fractions into improper fractions? I mean, you have to change it to mixed numbers. Then I told you, oh, guess what? We're going to leave them as improper fractions now. The higher math we go, because when we deal with numbers, we don't like to deal with irrational numbers. We're going to leave this in terms of pi. Okay? So, 36 pi is the area of the circle, but now when we're finding the area and we have to combine it with different shapes, we're going to have to multiply it out. But I don't want to do that yet. Because what is this, the area of? Which circle?
The whole.
The whole circle. That's the area of the whole circle. What do we need? Half of that. So if I divide that by 2, how many pies does that leave us with? That leaves us with 18 pies. Right? Because pretend that's a variable, 36 divided by 2 is 18, so we have 18 pies. Now in your calculator, 18 times the pi button and give me what you rounded to the nearest decimal. 18 times pi button, what do you get?
56.5.
All right, we'll leave it at 56.
25.
Let's just leave it at 56.5. Is that all right? 56.5. So that's the area of the semicircle, but again, we have to find the area, okay? So we got 228. We got to find the area of the whole thing. 228 plus 56.5. What's that equal? 284.5? Is that right? Feet squared. So that's our area. That's our area. Now, we got to go perimeter. We got to go perimeter. P for perimeter. Perimeter is just all the sides, right? But what kind of shape that's going to make it a little bit more tedious? Circle. On your sheet, what is the formula for the circumference of a circle?
Oh, I said that. 2 times. 5 times.
2 times pi times r?
Yeah.
All right, so what's 2 times r? What's r? Yeah, so can't we just say pi times the diameter? We can't here because it's 6 squared, but we can here because 2 times 6 is it's the same as the diameter. So there's 2 formulas for circumference. It's 2 times pi times r, or pi times d. So we got this side right here, which is 19. We're going to need that. What's this side right here? 12. What's this side right here? 19. We don't count this interior side because it's not on the outside. We have to go here. And that's where we get circumference. So let's go circumference equals pi times the diameter, which is 12 pi's, right? So wait a minute. Wait, come here, this is fun. Do we need the whole thing around?
No.
Do we need all the way around the circle?
No.
We only need what? Half of it, right? So how many pies? 6 pies, which equals what? 6 times pi button, what does that give you? 18 what?
Wow.
18.8. All right, so now we got to add. So the perimeter would be 19 plus 12 plus 19 plus 18.8. In your calculators, what do you get?
A number.
Can you just add it together for me?
Yes, I put it.
38, 40, 50, 68.
68.8.
Now, remember, perimeter is linear, so we don't write feet squared, like I just did. We just write feet. So that's the perimeter. All right, so here's your homework. It's easy.
Oh.
Watch, come here, it'll be fun. It's just the examples on the back that you have to finish for homework. Now listen, what shapes do you have up here?
A spaceship.
Triangle, rectangle, and trapezoid. How about here? Semicircle, rectangle, triangle. Here's what I would do. I would do this whole thing and then just subtract out that little nook or niche or cutout right there, okay?
Okay.
All right, that was.